Okay, hi everybody, and welcome to our regularly scheduled multi-tenancy working group for Kubernetes. Today, we're going to have a presentation on Arctos and Kubernetes multi-tenancy, and then Rodolfo is going to talk about CRD management and multi-tenancy.
Okay. Hi, everyone. This is Xiaoling. I'm going to walk through the Kubernetes multi-tenancy in Arctos. This feature is a joint work from Chen, Peng, Hongwei, and me. They are also in the meeting today. This is what I plan to talk about today. First, I will give a quick background and overview on the project, so you guys know what's the context and what we are doing. And then I will walk through our design. I will give a quick update on the current status and what's next. And then lastly, I will show a demo. So here is a background. Arctos is an open source project. We target for use Arctos to build a really large scale cloud infrastructure. This project is open source and it's licensed under Apache 2.0. Arctos is derived from Kubernetes, but with some core design enhancement. By deriving from Kubernetes, we mean we take the Kubernetes code base and applied our design enhancements on that. So far, we are mostly working on this key enhancement. First is the native VM orchestration, multi-tenancy, and scalability, and some cloud edge scheduling. And for today's talk, I will only talk about the multi-tenancy part. But if you are interested in any other features, just feel free to check out our GitHub repo. And all the design documents and the PRs codes are all there. It's all public.
Sorry, can I just ask one sort of background question before we go on?
Sure, no problem, no problem.
Yeah, is Arctos intended to be like a research platform or a production platform? Like, are you just looking at experimenting with features that might be upstreamed, or is this supposed to be a product in its own right?
Oh, actually, it's kind of in between. We are all from FeatureWay. We are based in Seattle. We ourselves are kind of a research group, but this project will be a standalone project. We also looking for industry adopters, because only by getting feedback from the real production environment we can move forward. So it's kind of in between. We test some ideas here, but we also want to be adopted in the real production environment.
Okay, thanks.
And for all the features, if the Kubernetes community is interested in, we will be very happy to work with the community to upstream them. That's also one of the reasons why today we reach out to the multi-tenancy working group. We first want to get some feedbacks, establish a connection with you guys, having some regular technical discussions. And if you guys are interested in any multi-tenancy features, we are happy to work with you guys to upstream.
Okay, thank you.
And this is an overview of our multi-tenancy feature. Overall, our vision is that we want to enable multiple organizations to safely and easily share a physical cluster infra. We all know that there are different models of multi-tenancy. What we implement is a kind of virtual cluster model. We know in the community there is also a project called virtual cluster. The difference here is our virtual cluster is based on one copy of control plane. It's kind of built-in changes, native changes. We don't deploy a separate control plane for each tenant. Instead, all the tenants, they share one running control plane. And they are all isolated. If we look at the diagram on the left side, we can see there are two tenants. Each of them access the physical cluster as if they own the physical cluster exclusively. And they are also using the native Kubernetes API. In fact, for these tenants, they probably even cannot aware they are on the multi-tenancy environment. It's all transparent to them. They feel like they are using the original Kubernetes in an exclusive way.
And just a question, is this virtual cluster the same as the virtual cluster project that Faye and Co are working on?
Yeah, that's what I just briefly mentioned. Yeah, when we are aware of that there's a virtual cluster in the working in the multi-tenancy working group. The way
just wanted to confirm this was the same thing.
Yeah.
Thanks.
We have some design principles, but I'd like to come back to this later because after we understand our design, probably it's easier to understand these design principles. Our whole design is based on a concept called a space. This space is actually a new layer in the resource hierarchy. So with space, we break the whole API server into different pieces. Each tenant has a space, and inside his space, he can have all its resources. And each API object will be located in one space and only in one space. Here, I put two examples. You can see on the left side, we have a pod, which is a namespace scoped object, right? And a PV is a non-namespace scoped object. And they are both on the space called T1. Due to some historical reasons, in the actual code implementation, we use tenant for space, but they are actually the same. We probably will change the naming later. And on the right side, you can see how physically these objects are stored in the etcd. And to help developers easily to tell which space an object is located in, we introduce a new field in the object metadata section, which is here. You can see the example. So we use space to isolate tenant resources. This is one. This is and also the most basic thing. How the space and the tenant get initialized? We have a built-in space. This space is called a system space. So it's kind of it's a reserved name. Any other tenants cannot create a space called system. All the system level resources like nodes or some system cluster configurations, they are in the system space. And we introduce a new API object called talent. Here is an example YAML file for the talent object. Whenever a talent object is created in the system space, our talent controller, which watches the talent object, will kick in, and it will create a corresponding space for this talent object. And it will also initialize this space with this default namespaces and also other default objects. So this space will look like to the talent will look like the whole Kubernetes API server. Here we have 3 talent objects created in the system space, and correspondingly we initialize the 3 spaces for these 3 talents. And inside each space, you can have all the original Kubernetes resources, regardless they are namespace scoped or unnamespace scoped.
So, quick question. Does do these essentially spaces allow you to also create tenant resources of their own, or is it a flat hierarchy?
Oh, this is a good question. For now, we are focusing on virtualized Kubernetes features. We didn't introduce new features like a hierarchy namespace. We didn't introduce that. But technically, for the hierarchical namespace improvement, it's probably can be implemented. It can be used inside one space.
I was specifically talking about the tenant resource that you have here.
Yes.
Right. So if I'm in a space, is the tenant kind available to me to create another one? And is there also a system space inside that space, or are the spaces flat?
It's a flat. It's flat. Any object within one space, and the system space is just one. Is just the first space that created by the system during cluster bootstrap. They are all flat. There are no nested spaces.
Okay.
Can I ask a question?
Sure.
Yeah, this is Fei. Are you saying that, so what is the progress of creating a namespace? Can you create it directly, or you have to go through the CRD?
Create a namespace or space? Namespace,
regular namespace.
You can create a namespace in any space. Here you can think of a space as a virtual Kubernetes API server.
Yeah. So actually, my question is, I don't quite understand why you need a CRD. I mean, why do you need a controller? Because if you have a built-in meta, why do you need a controller to create? Because I don't quite understand why you have to use a controller to create all the namespaces for team space. Or what's the purpose of that controller?
This controller is responsible for the space initialization and cleanup. Because when we create a space for talent, it's not an empty space. We also create a default namespaces like a kubesystem default and some other resources which I can talk about later.
I see. Thanks.
Yeah. So we have a space, and we can create a space for talent, and the talent can create all its resources inside the space. So all talents are isolated, but there's a big problem. Well, after we introduce this, we actually break the API compatibility, right? Because for all the API resources, you can see the resource URL has changed. We inserted a new layer there. To solve this problem, we introduced a new concept called short path. This is really a key part in our design. This short path makes the whole API backward compatible and make all our changes almost transparent to tenant users. The idea actually itself is simple. We modified the endpoint handlers in the API server. Users can use a full path to access the API object, or they can use a short path to access object. If this endpoint resolution part couldn't find the target space in the URL, it will get that information from the access credential associated with this request. This diagram gives an example. Yeah.
This implies that every user can only be a member of exactly one tenant?
Yes, because user, for now in our model, a user belongs to a talent, and that talent is a part of the identity of the user.
And can I, let's say, log out of one tenant and log into another? Like, can I switch contexts between tenants in the same way? Okay.
You can switch contexts on the client side. When you use a different credential or different context to indicate that you belong to another tenant, this resolution will automatically resolve to the other tenant space.
Okay, so like today, if I want to switch from one cluster to another, I can use the same credentials because I'm still me. Like, there's no change of identity, but I can be part.
Yes.
But in this model, you actually need separate set of credentials for each tenant that you're a member of, correct?
Yes, for the multiple tenants in one identity, that's not addressed in our current design. We plan to sort in the next stage. For now, we assume one user belongs to one tenant. Yeah.
Okay.
But this is a very good point.
Okay, thanks. Yeah, like that's one reaction I have right now is that I would want to operate. I would be a member of multiple tenants simultaneously. For example, like imagine I'm a super admin, and I'd want to be able to. Or is that only needed for the short path resolution? Like if I'm...
Yeah, that's only for the short path resolution. You can always use the full path to access any desired space.
I see. Okay, so basically, like every user has a default.
Yeah, yeah. And
Okay.
if your user belong to system tenant, it can access any test space. That's our
I
current.
see. Okay, thanks.
So in this diagram, I give an example. We have two regular tenants, T1 and T2. They issue an API request. They still use the original API. They access this same object, pod P1 in namespace NS1. But after this short path resolution, it will be automatically changed to the full path to the corresponding space object in the different spaces. But to this tenant users, these are all transparent, which means they can use all their original Kubernetes API and the tools like Kubernetes and all this stuff. The short path implementation heavily relies on the access control part. The way we did,
Sorry, go back. I just have one question. So, what if there are some other components, like if Kubernetes wants to access some part, or
you mean our controllers, right?
Yeah. Like
yeah.
Kubernetes is one of the controllers.
Yeah, I will cover that next slide. But for now, I can quickly explain. For all our controllers, they are running using a system credential, and they can list watch all the objects across spaces.
Okay.
It's also transparent to it. But inside the code.
Let me see. But what if they want to use the short path? Do they need to? Because
in fact, they are using short paths. When they list watch using client Go, most of the time they just append a new parameter called tenant.all. They will list all the objects. If they want to access a specific, then they need to put the tenant name in the API call.
But how does Kubernetes figure out let's say Kubernetes, how does it figure out the tenant name?
Oh, that one is in the API object.
I see.
Let me give an example. Let's say you have a job controller or Kubernetes, right? It needs to watch all the pods object. So it still use the original code, but in the list watch API call, it use additional parameter called tenant all. It will get all the objects. And then when it processes each individual object, it knows each object belongs to a specific tenant because we have this field.
Okay.
In the access control part, for authentication, we support all the authenticators. We just add a new field in the corresponding authenticator. For example, in the cert, we use the CN for the tenant name, and for token and the key, we append an additional field to indicate which tenant this user belongs to, and we put it as the last field, so it can be compatible with the original identity definition format. So after this change, we know which tenant a user belongs to. And in the authorization part, for now the rule is very simple. If a user belongs to system tenant, it can access any space. But if a user belongs to a regular tenant, it can only access its own space. We plan to support cross-tenant access, but that's not done yet. We are working on that. All the other access control, they are still performed by the current Kubernetes access control mechanism, like the rule and the cluster rule. So the code change here actually is not big. It's very small. We just add some additional checks in the ABAC authorizer or ABAC authorizer, like this. So
Sorry, continue. I'll ask my question.
Sure. Feel free to ask. Yukimi, do you have a question?
Yeah, I was just gonna wait until later, but if you're okay with asking now, I'm a little curious about how the list watch works in the situation where you have custom resource definitions in different APIs from the system scope.
Oh, you mean the CRD in tenant spaces, not in system
Yes.
space?
So I have CRDs in tenant spaces, and I'm at the system scope, and I'm going to make a request over all of the tenants for a GVK to do like a list watch or something.
Yeah.
They could all have different schemas, right?
Yes, I have one slide dedicated for CRD.
Oh,
Can we defer
cool.
the? Okay, I will talk about that
Yep.
on that slide.
Thank you.
Thank you. So this is the general access control, and this is a diagram how we do the resource access combining access control and the shared path. It's basically we first check if the target space here if it is specified or not. If it's not, then we try to infer the space from the user identity. If it's already inferred, then we just check if it's a cross-tenant access. And then we go to the normal access control code path with this rule and cluster rule. We can talk about all this detail later if you guys are interested.
Hey, one question. So a lot of the Kubernetes RBAC is all based on sort of users and groups.
Yes.
And here we are introducing the tenant explicitly in the authentication.
Yes.
But the RBAC policies are going to be based on the LDAP groups.
Yeah, we didn't change that part. We only, first, for user identity, Kubernetes has a username and a group, right? We still keep that. We just add a third property, which is talent. And in the RBAC, we keep all the original code. And we just add additional checks on this talent property.
I guess where I was going was sort of some sort of potential mismatch between the tenant and the group. Let's keep going. Maybe I'll formulate it.
Okay.
Yeah.
And now we talk about the client Go and the controller changes. All I talked about earlier was about the changes in API server, right? For the client Go, we add the talent as an additional parameter in most of the CRUD methods. This part, actually, we can optimize the design since in the latest version, we introduced context in Kubernetes client Go. And we also define a special name tenant.all. It's like a namespace.all. So you can, if the controller is running as a system credential, it can perform cross space list watch. For all the controllers and schedulers, they need to make some small code changes. This here I list some example code. It's a kind of typical changes. All these changes are very similar. They are not related to the controller specific logics. It's mostly about when you list your interested objects, you use talent.all, so you can get all the objects from all spaces. And then when you do, when you do object querying, updating, or correlation, for example, in a controller, you probably need to correlate a replica set object to its pos object, right? Previously, only based on namespace and the label select, but now you need to put an additional comparison, compare this talent field. That's all. All the controllers, the changes are very similar. Actually, we already finished the changes on about 15 controllers. It's pretty quick.
I have a quick question about ownership. Do any of these spaces have ownership over sort of all the objects that they encapsulate? Like what happens if I delete a space?
What happens if, sorry, I didn't get last part.
If you delete a space, for example.
Oh, when we delete a space, currently we are following the same philosophy when we delete a namespace. All the objects will be deleted. there are some probably tenant data retention policy stuff, but we treat that as a kind of outside module. We don't plan to do it inside in the kernel.
Okay, thanks.
Hey, Ewing, so this tenant all, so that will it like allow to list all the tenants cross tenant, or is there a way to selectively like define which tenant can be watched or listed?
Oh, first it depends on your credential, right? If you do not have permission to list all, of course you will not get the resource. And second, if you want to selectively list some resources from some spaces, you can add this list watch filter based on the field in object meta.
Okay.
Sorry, is this one? Yeah, you can add a list watch filter based on this field.
Okay.
On this slide, I want to talk about how talent can self-manage themselves, because we want to enable a talent admin to manage its own resources or virtual cluster without turning to the cluster admin every time. So we kind of we reinterpret some concepts. For example, for some regular operation like creating namespaces, resources, pods, they are already isolated by space, so they are no problem. And talents can also reuse this like a cluster rule or cluster rule binding or resource quota. It's all same to the talent admin, but these objects will only apply to its own space. For example, if a talent admin creates a cluster rule binding, this will only apply to the namespace within its own space. It's kind of transparently limited to its own scope. But this whole thing is transparent to the talent admin. He doesn't know this has been limited. He thought he's working on the whole entire cluster. So with this approach, a talent admin has the full authority for its own virtual cluster. It doesn't need to turn to the cluster admin. And I forgot to mention, a talent admin or a talent user can also install CRD, and this will only apply to this talent, and it will not impact other talents. And this has been, I can introduce more details about it. Previously, we have a question about the CRD support, right? In our design, we already implemented this, and we actually divide the CRDs into two different types of CRDs. First, we call it the excuse me. First, we call it a per talent CRD. This is all backward compatible. A talent can install any existing CRD and operators without any modifications. You don't need to change the YAML files or operator codes or recompile operator codes. It simply runs as it was before, but only inside the current talent space. If we look at the diagram on the left side, let's say we have 3 talents, and each talent install a different CRD. This CRD will only be visible to the current talent. It will not impact other talents. But during the implementation, we realize there are some CRDs that will be commonly used by all talents. For example, now some virtual networking solutions are based on CRDs, and some storage solutions are also based on CRDs. This is very likely to be used by all the tenants. Technically, we can still deploy them as a per talent CRD. But imagine on a large cluster, let's say if we have 1,000 tenants, then we need to deploy 1,000 copies of these operators and the CRD definition. So to optimize this, we introduce a new concept called system CID. For system CID, you only need to deploy one copy in the system space. And then after you test it, you find it's working fine. You apply a special annotation on this CID. And then it will be automatically visible in all the tenant spaces. The good thing is with this system CID, you only need to deploy one copy. You don't need to run the operators in all the tenant spaces. But the requirement is for the operator, it needs to do some slight code modifications to use tenant.all to watch all the CR objects in different namespaces, in different spaces. This is very similar code changes for our built-in controllers. I don't know if I addressed the previous question about CID or if there are more questions about CID.
I think we missed it a little bit. Well, the question was particularly about in the left per tenant CRD.
Yes.
Let's say I have a controller or a user at the system scope that is doing a list on tenant all for a particular GBK. Now, you can't really be guaranteed that the schemas of those CRDs will be the same, even if the GBK is the same across the spaces, right? And I imagine there's situations where a system CRD shares a GBK with a tenant that has the same GBK already installed at the tenant scope.
Yeah, I think yes. This if you combine, if you list watch use tenant.all for this, there could be schema conflicts or differences. Chen is also online. Chen is working on this part. Chen, I don't know if we think of this case.
Hey, this is Chen, and I'm the one who is working on CRD. Now it's like we are working with for once we have a system CRD, we think like it's the one that will take the control code. Basically, the system CRD will covers the per tenant CRD, so you won't see the per tenant CRD. That's our design so far.
Yeah, yes, I understand the question is even on the per tenant CRD situation, users potentially can list watch all the CRD or CR using tenant.all, and there could be.
But for per tenant CRD, like as a tenant user only have the visibility to its own space, so you don't need to make code change to your operator or your CR. But like all you can see, it's just the resources, the definition in your own space.
Well, what if a user, let's say system user, list this user tenant.all?
That one is like, so the system CRD as the system tenant now when he's listed the custom resource, he will see the custom resources in all the tenants, all the tenants. Yeah, that's so that's our behavior now.
Yeah,
I think. Sorry, go ahead.
Sorry, go.
I think you're concerning about the schema conflict, right? Is that a question? So basically, it's I would like say if once we have the system CRD, basically that one, the designs the system one will take control because we want to once the system tenant deploy or CRD, we want it to be consistent across the whole cluster. So it will kind of overrides.
I think the question is, and Nick, correct me if I'm wrong, but I think the question Nick was asking is, let's say the two tenants have installed different versions of the same CRD, but they didn't like actually record them as different versions. So they both happen to install a per tenant CRD called foo, and then the system user lists all objects that are of type foo. In that case, that the resulting list that you get will have resources from two different spaces with two different schemas. Nick, is that your question?
Okay,
That's
I got
exactly the question.
Okay, thank you for clarification. I got the question now. It's like, okay, the solution is like two tenants, regular tenants, they have their own CRD, and they have their freedom to define their CRD. So for same GVK, they have different schemes. So in that case, you see in the picture on the left, actually the system tenant does not have idea on this CRD. So for such per tenant only CRDs, we don't have a release watch because in system space, you see there is no such a corresponding. Only tenants, because in that case, that's what we said, autonomy of per tenant. The regular tenant have totally control of their CRDs.
Yeah, so it's a similar situation for like sub-resources. Like if we used an analogy, like sub-resources of, you can't do a list of the status across a set of resources. You have to get the entire objects. It's a similar situation here. I can't do a list across the CRs for several tenants.
Oh yeah, I would say that's a very good the comparison. Yeah, I like it. Yeah.
Okay, so that makes sense to me.
Thank
All
you.
right, thank you. Sorry for derailing.
That's okay.
Thank you.
Hey, Tasha, I just realized I have used 40 minutes. Do I have more time or should I speed up? I probably need probably 10 more minutes. I don't know.
Yeah, it seemed like people were really interested in the presentation, so maybe we'll just finish it and we'll, Rodolfo, if it's okay, we'll have the conversation you wanted to have at the next meeting. Is that okay?
Sure, yeah. Because I see that the other topic is about the CRD and multi-tenancy, and maybe we can combine together. If you guys have more questions regarding CRD, we can discuss here. I hope we can address this together.
Yeah, I feel like a lot of the issues would be overlapping, because I think what Rodolfo wanted to talk about was the possibility of adding namespaced CRDs to Kubernetes as it is today. And I think you'd run into a lot of the same kinds of issues, like what happens if I do a list across multiple namespaces? Now I'm going to have different schemas and different namespaces. So that's I think it's good to talk about both of these, but yeah, I think at this point we won't have enough time to do Rodolfo's.
Okay,
so
yeah. I think we can discuss more details in the next meeting. I expect this will be kind of long time, kind of communication or collaboration. This is today is just our initial effort to establish the connection with you guys, and we want to have more discussion later. And so far we have talked about the control plane in our design, but there are also isolation in the data plane. In data plane, for the runtime, I mean the OS kernel isolation, we use the kata to support that. And for storage, so far there are no changes because most of the storage providers already have provides the volume-based isolation. The most complicated part is in network, because so far the Kubernetes has a flat network model. Each pod is reachable from another pod, right? And relies on network policy to do the restriction. But when you have multiple tenants sharing one single physical cluster, you don't want the tenants worry about this IP allocation or IP conflicts. So we introduced a new multi-network model, and currently we are still working on that. And so today I don't have time or too much detail to share. We can discuss later if we got interested. But the key idea is that we introduce a new API object called network. This is a kind of abstraction of an isolated network. This API object type is like the network policy object. It can be implemented by any external network providers. For example, you can use a VPC-based service to implement this network object, or you can use some other updated flat network provider to implement this.
And are networks one-to-one on spaces or tenants, or can you have multiple spaces that share?
They are kind of one-to-many. So each tenant has a space, and in each space there's a default network object created. And the tenants can create more network objects based on its needs.
And what happens if two tenants want to communicate with each other? They just have to use a non-Kubernetes networking
Yeah.
solution.
For now, we only support this through the public IP to communicate each other. We haven't reached into that part, the cross tenant.
Okay, thanks.
Well, didn't the network attached definition kind of do some of this?
This network object definition, for now.
No. I know what you're introducing a new object, but there is something called a network attached definition that seems like Multos and other things are relying on, right? So there's already a network object that I think gives you some of this construct.
Okay.
You can provide IP space and static routes and unique DNS and defaults and things like that, and you can associate them with namespaces. It felt like you could always use that and expand it to support spaces, if you will.
Yeah, maybe we, yes, thank you for suggestion. I think we can check more details on that part, yeah, to compare that. Okay, so for network part, it's more complicated, and we can talk about more detail later. For now, it's kind of just an overall introduction of this part.
Yeah, I think for networking, the biggest problem is your class IP can be the same for different tenants, but the nodes are shared. So the IP.
You were talking about classed IP or pod IP?
Classed IP service, because.
Oh yes. Service is a tricky thing in handle. In our model, each service also belongs to a network, and each network can define its classed IP range. They are all kind of isolated.
Yeah, I know, but the problem is inside the node, the node IP table is not tenant aware unless you change that.
No, yeah, we don't now. We do not require IP table proxy. Depending on which network provider we use. Like for example, now we use a VPC-based provider to implement a network object. On the node, it's actually not the traffic not going through proxy. It's going through this provider specific packet handling.
Okay.
Is the primary goal there wanting to have uniqueness of IPs, or as long as there is network isolation, it doesn't matter whether each one have its own IP allocation? Like for example, if there was a network shared between two tenants or two spaces, as long as the isolation was guaranteed between two different tenants, does it matter whether they're sharing a network or not?
Oh, yeah, this is a good question. Because in our design, we want to support most demanding scenario, which is a public cloud. In that scenario, each tenant shouldn't be aware of each other. So if you are sharing one network, but you're using some policy to limit the access, one tenant can still feel like the existence of other tenants, because some IPs they are not available. Some IP are available. They need to know which IP range it can use, and it can detect something on the L2 level. In our solution, we want to do the most strictest isolation. Even on L2 level, it's isolated.
Yeah. So just one quick suggestion: there could be that your overall multi-tenancy solution looks pretty promising, but it could have either shared or multi-network model as two variations, so that if somebody doesn't have to necessarily have the multi-network model in order to do the rest of your stuff.
Yes, this is a very good question. Actually, for the network part, our network object is defined as a CRD. We are wondering if this can be a standalone effort, just as you described. Some people probably want to use multi-network, but doesn't necessarily use the full multi-tenancy model. We are working on this part.
As somebody else said earlier, there is a multi-network work going on in the networking SIG, so you should look at that.
Yeah, we probably need to kind of talk with them more. Thank you for that. And this is our current status and next.
One question.
Sure.
So how are you associating the networks with the pods or the workloads? Are you associating at the namespace level, or are you associating at pod level?
Oh, for all the like objects like pods, service, and network policy objects. For now, we are using a special label. Hongwei, is label or annotation? I forgot to associate this object with the attached network.
Okay.
Mm.
This is Hongwei. I am working on the networking part of Actos. It is label. The network is use label to associate.
Initially, we wanted to use a new field to associate this objects and network, but because we want to make this multi-network kind of a standalone effort, so now we are using label.
So label or annotations, sorry. You're using annotations to specify which network attachment definition to attach with, or
no. Now we are using labels.
Okay.
Mm.
Yeah. By the way, using label has one more advantage. It works very well with network policy, existing network policy, if we want to reuse them.
Okay, yeah, I think there are a lot of things here that we can go into further detail in future calls.
Yeah, yes, that's a big part. Well, I think it requires a lot of discussion to cover all the details.
Okay.
For
I'd love to ask one sort of high-level question, which is to compare this with virtual clusters. It seems to me, and tell me if I've missed something, the biggest difference between this approach and the virtual cluster approach in terms of features is that this approach maintains some kind of concept of sharing between the different clusters. You can have a super admin who can, by making calls to the same endpoint, can see stuff from the different spaces. Whereas with virtual clusters, there's essentially no sharing at all. Like there's no system space, there's no equivalent of a system space. But other than that, they appear to me to be quite similar. Is that a fair?
Yeah. One difference is this cluster cross talent management. The other big difference is I think it's probably more related to the resource consumption or something. Because let's say you have a large cluster, you have thousands of talents, and in our model, we just sharing one copy of software, right? We do not deploy thousands of kind of separate small control plane for each talent. I'm not saying that that's bad. I mean, there are pros and cons for both approaches. They are kind of alternative for different situations.
So just to be clear, let me just quickly ask this. So are we saying the difference between this and the other virtual cluster is maybe some simplistic way of saying is in your mind, and so forth? Right?
Yes, it's one deployment with built-in native code changes to support multi-tenancy. The other model is you deploy basically a small class control plane for each tenant, right?
Yeah, and that's, I understand the difference in implementation. I guess what I was wondering is, what are the features that fall out of that implementation decision? And I think that the answer is that in virtual clusters, there is no concept of sharing because each API server is kind of a world unto itself, whereas in your model, because the API server is shared, you've been able to add these features to allow the system namespace.
Yes,
sorry, system space.
Yes, we have potential to do all this kind of cross-talent sharing or management stuff because they are within one kind of physical thing.
Okay. Faye, that all sounds, you agree with that description?
Yeah, I think the majority differences between the API server and so everything and the API server, we share the same problem with the networking. I probably will ask because, yeah, by the way, let me quickly ask one question. So how do you handle the node object in the?
Yeah, this is a very good question. For now, we still keep the node in system namespace. So user.
That's always the problem because now, because you suppose user can add annotation. So you are kind of escalation your privilege to let a user namespace to change your system namespace object. But anyway, I know we've kind of sharing the same problem. But
for now, the regular talent users do not access the node object, but there are some kind of inconsistency because they can still see the node name in like the pod, some pod fields.
Yeah, it's kind of virtual class probably share the same problem, but we do it in different ways. We create a virtual node object inside the tenant, so we have a one level of abstraction. But
yes.
Beyond that, it is kind of pro and cons. So virtual class to consume more resource. The benefit is has dedicated control plane, and you probably have a smaller, disaster, kind of a radius of the failure radius is smaller, because one tenant, if they do something, just get on this own API server, not a whole thing.
Agree.
Well, your model definitely is more efficient in terms of resources, but the cost is you have to change the API server. You probably will introduce the compatibility issues, and you probably have to make sure the other plugins have to make some certain changes. That is efforts that that integration efforts that I would say may may introduce the issues when people want to actually use it. But indeed, I think from multi-tenancy perspective, some of the your changes is the one that we have for a long time to be changed to upstream. So did you ever consider upstream to leverage some of your ideas?
Yes, we as I mentioned earlier, today we first want to have the initial touch base with you guys, and we establish a connection. And if you guys are interested,
I think Sig machinery is the one that you probably have to.
Yes, we understand this is kind of a challenge work, because lots of, as you can see, lots of changes. They are kind of built-in changes, like in the point resolution. So we expect it's kind of long-term effort if we want to upstream this feature, but we are willing to.
We're a work group, and so I think this is the right place to start this discussion, because the machinery SIG would want to come to us and say, well, hey, what do you think? Does this, because of course machinery is one part of this change, but there's a lot more to it. There's also networking and many other, and storage and many other aspects of this as well. So yeah, no, I think you did the right thing coming to us. Not sure what the next steps are. I think
this is really good, because in theory, this is in fact true multi-tenancy. It appears to be with a shared control plane, but practically there are some, scalability could be another concern, because you're presumably having one etcd with one control plane, and it sort of has to capture the state of all tenants, right?
Yeah, in the Arctos, actually, I listed earlier, scalability is another bigger feature we are working on. We introduce multiple etcd clusters, and we partition API servers, and we make controllers active mode. So that's another part. But if you guys are interested, I can talk about them in next meeting or something, or in other situations.
Do you have a working demo at which you'll be able to share?
Yes, we already used 1 hour. So let me use several more minutes to quickly show a demo. And for all the other details, if you guys are interested, I think we can discuss in email or in the subsequent meetings. I don't think we can cover all details today within one meeting. Here, I prepare a simple demo. You can see I have 2 terminal windows to act as 2 different tenants. They are all talking to a same physical cluster. The only difference is you can see they are using different kube control config. So one is tenant 1, one is tenant 2. So initially they look the same. They are using they are under 2 different tenants. Now let's say if I create, I first demonstrate that I create some resources with 1 tenant. First, you can see it's all transparent to the tenant users. It's like tenant even cannot feel the difference. It's just user same command lines and see the same thing. And let's say if I create a namespace demo. I see the new namespace. but on the other side, on the other tenant is still the same. And now I create some pods and the replica sets, all this stuff, just like what I'm using when I'm using the native Kubernetes cluster. I forgot. Let me see. What's the YAML file name? I create a pod. I create a deployment.
Can you create a pod in the kube system namespace of one of the tenants?
Let me see. You want me creating the kube system, right? Name.
Just do NS.
Oh.
Or dash dash.
Dash dash, yeah. You can see it's created there.
But not in the other one's name kube system on the right side.
No. If I search, if I get the it's all empty. Yeah, these are totally isolated. If I get all the pods, there are no pods on this tenant. It's all isolated. And if we look at this
on the left side, the Kits vanilla pod 2 is both in kube system and in default.
No. This pod 2 is the one I created earlier.
Different. Okay. Yeah.
In default namespace. And if we look at this YAML file, it's all same. You don't need to make any changes. You still use the kube control, so you don't feel anything difference. So this is the first thing I want to demonstrate: how how tenants are isolated and how these changes are transparent to customers. And the second thing I want to demonstrate is some management work. Let's say if now I'm acting as a tenant admin. Now if I want to I think context equal the context I set. Oh, this is on this tenant I forgot. Yeah. Sorry, I didn't. I prepared this demo in a hurry. Let me. What's the name? Config. What's the context name I'm using? Tenant. Oh, tenant Xiaoling. Okay. So you can see now if I'm using tenant admin to get pods, I get the.
Kubectl. Spelling of
Oh, okay, I see again. I just created. I think there's something going on.
I think you changed the name to a kube system namespace, right?
Yeah. The namespace change it. You change it to kube system.
Let me see. Oh, I see. That's the reason. Okay, I see. Get it. Because I already created the namespace. Now I create one in the default namespace. Okay, you can see I can get the pods. But if I'm using regular tenant user, I cannot get the resource. So now I'm then demonstrate a management task. I create the cluster rule binding and grant the permission to the user. If we see this rule binding, it's all the original Kubernetes thing. You don't need any change. This rule binding grant the user Xiaoning the permissions. So now if I select pause, I will be able to see it.
Sorry, I missed the earlier part of your discussion. How do you guarantee uniqueness of the cluster roles names and the cluster role binding?
First, this object itself is within one space. So each tenant can create the rule binding or rule objects without worrying about name conflicts, right?
Including cluster roles.
Yes, everything. Rule binding, cluster rule binding. And the second, in our RBAC authorizer, we only interpret this object to the current space. So customers still use the same object like a cluster rule or cluster rule binding, but that one will only take effect on the current space. And this is all transparent to the tenants.
Okay.
So tenant admins can do the self-management. They can manage their tenant space. They don't need to worry about and talk to the cluster admins. And the last part is I can create I quickly put some CRD definition from the Kubernetes Kubernetes documents. And then now I'm creating CRD in this tenant, and I can see this CRD gets created. And on this tenant, if I try to, it says nothing. And I can continue to create a CR custom resources. CR, yes. I can see these objects get created, CR objects get created. This is cron tab. Yeah, this is a custom resource gets created. But if I try to create this CR resource, other tenant, it will complain error because there are no CRD definitions visible in that space. All these tenants are totally isolated and they are transparent. They work as if they are working with native Kubernetes. It's transparent virtualization.
You do have kubectl API resources in both the tenants.
I'm sorry?
Kubectl API resources.
You mean API resources?
Yeah, I'm not sure if there's a hyphen between API and resources. Maybe not.
API dash resources. No, this one has no CRD that defined, so we don't see the contact, but it can write in the.
Sorry, somebody's speaking very quietly and I can't.
Yeah, Chen, you probably need to come closer to the mic.
Oh yeah. Sorry, this is Chen. Okay, so Xiaoning, I said you use kubectl or API resources on the left side. You should not see the cron tab, but if in the right side, because we have CRD of cron tab.
Okay.
Fine. And we can use the grab to see it.
Yes. It's there. This is called a cron.
Yes, in the last, next to the last one, you see the cron tab. Yes. You see it's there.
There's a cron tabs. Let me on the left side. There's nothing. Okay, this is all my demo and today talk.
Yeah, very cool stuff. Good stuff.
Yeah, thanks.
Yeah, cool demo.
Yeah, yes, we know there are lots of kind of multi-tenancy is a complicated area, and there are lots of details. And because we take the native approach to make Kubernetes multi-tenancy, so it's very challenging to probably to upstream this. So today is just our initial effort to establish a connection with you guys. We want to have more discussions and in later meetings.
And Shani, maybe you want to share the last slide. There are some useful links there. So.
Oh yeah, sorry, I forgot to share. And this is some links. I can share the slides link in the email group. And this is our kind of project repo, design documents, roadmap, and all this other stuff. Feel free to check out. It's all open.
Okay, yeah, thank you. Yeah, let's continue this conversation in Slack and on the mailing list. And if people have a lot of questions that come up, we can discuss them at our next meeting too. But yeah, thank you for this presentation. It was great.
And thank you for our time. Thank you all for the time.
Thank you.
And for this good question and feedback.
Bye.
Bye-bye. Thank you.
Bye.